Okay, sorry for the delay. And this is UI tests are fun to write if you write them right. Now I wanted to start with a quick sort of the obligatory audience survey, but I can't see half of you because this light, and many of you who are in theaters I can't see, but we're going to wing it. I will assume each of you counts as like 5 people, so your vote counts. Quick show of hands, how many of you are currently writing UI tests on your projects? Okay, maybe a little less than half, maybe. Did anyone here used to write UI tests but gave up because it sucked? Okay, some more hands. And those of you who have done it before, how many of you enjoyed UI tests at least as much as other types of tests? There's like 3 sick people here, or maybe you had the secrets already and you should be up here, I don't know. But not very many people. And I'm not going to lie, I generally dislike UI testing. I think UI tests are hard to write. I think they're hard to set up. I think they take a long time to run, and that stinks. You can't run them in parallel. They can be hard to troubleshoot. They make permanent changes to your database or your file system. And that makes it hard maybe to rerun them if something failed and you want to make a change and test it again. So there's some challenges. And if you don't write them right, they can be very brittle, right? Even a tiny CSS change can knock a whole suite offline. And because the tests take so long to run and troubleshoot, figuring out what's broken and fixing it can be real painful. So for those reasons, and many more, my team resisted writing UI tests for a long time. We've been producing a large and complex SaaS application for about 8 or 9 years, and we've been doing unit and integration testing since the beginning. So we have like almost 7,000 unit and integration tests. So you might think that with all those tests, we could very quickly release new code into production. That's the goal of this, right? But if you thought that 2 years ago, you probably would have been wrong, because no matter how many tests that we wrote, we kept having things like this, right? We'd have a bunch of green check marks in a test runner. Hey, all good, boss. We'd push a new build to production. Someone would log in, and they'd get some stupid error in the UI level that we had not been able to detect. So the unit tests tell us things like, if the electrical system is working, then this switch turns the lights on and off. That's really good feedback when you're designing that part of the system. And integration tests tell us things like, the engine will move the propeller at the right speed to move this boat through the ocean. That's also very good feedback. You can't really design your propulsion system without that feedback. But none of those things tell you the boat's going to float when you put it in the water. So we eventually realized that unit and integration tests alone were just insufficient to support a frequent release of a large or complex product. And if we wanted to maintain a stable velocity over time, which we desperately do, and if we wanted to avoid putting our users through this kind of experience, then UI tests are necessary evil. And that's because only the UI tests give us that confidence that our code's going to work when a real person comes in a real browser, hits the site to do something in their job. And we need that confidence to go live, right? There are only so many times that your users will sit on the deck chairs as your app sinks into the freezing ocean before they will find someone else's boat to get them around. In our case, we estimate that a full manual end-to-end regression test of the whole app would take about 8 man-days. And that's 8 man-days of repetitive, mind-numbing, non-life-affirming work for the QA team, and 8 days where we're not shipping new code into production, or at least we're slowing down, waiting for QA to catch up. Automating the UI tests does not mean we get rid of QA. That means our QA people can do more valuable things. They can do exploratory testing. They can look for edge cases in business logic, not the rote, repetitive, end-to-end stuff they don't want to do. That's just looking for very simple things that we could have caught elsewhere. So in general, the automated UI tests help us release faster and make everyone a happier camper. Now, unfortunately, there's a difference between knowing the path and walking the path. Our first attempts at UI testing were painful. We made lots of mistakes. We struggled to keep the test green. We had a hard time with test data. We just really had a hard time figuring out the right cadence to make this worthwhile. Well, we kept at it, and we kept looking for better and better patterns, and over time, our tests got better. And then late last year, one of the new developers on my team said something that inspired me to write this talk. We were discussing our patterns, and he said, when I first started writing UI tests, I hated them. Now I kind of like them. They're fun. And that quote is the reason I'm up here. Because it told me that even though we still struggle to kind of figure things out, occasionally we still have lots of things are imperfect in our system, we've solved enough of the pain points that new people joining the team enjoy learning about what we do, and they don't look for excuses to avoid writing these very valuable tests. And the point of this talk is to share those lessons learned with you. Right? I am not an expert in UI testing. I've done this on one large and complex app only, but we've been grappling with these things for the last couple of years, and we have some ideas and some patterns that work really well for us, and I think they might work well for you as well. Last thing I want to say up front is that there is no silver bullet in UI testing. It's all about trade-offs. Some of the things you're going to see today might not work for you. That's cool, right? I'm not here saying this is the only way to do this. I'm going to show you the ways that we do this and why, in the hopes that the reasons that we do these things will help inform your own decisions on your own journey. Now, no matter what you choose and how you go about UI testing, it is hard work, right? It takes some effort, but it's work that's well worth doing. And if you do it right, it might even be a little bit fun. Our agenda today is I'm going to show you how we decide when to write a UI test and when not to, how we use the PageObject pattern to write and organize our tests, how we deal with test data, and some tips for making your UI tests more resilient over time. You're not going to see any introductory slides on how to use Selenium WebDriver. That's the API that we use to actually automate the browser. If you don't know how to use Selenium WebDriver already, that's cool. You don't need to know that to get value from this. I'm going to focus a lot on our patterns, our practices, our techniques. That's what really matters, I think, to your success. And if you don't know how to do the actual WebDriver part, there's tons of things online you can search for, but you'll get a lot of value out of this, even without that experience. All right, so when should you write a UI test? And the simple rule is that you should write a UI test only when you can't write a cheaper, faster, or easier test that will give you the same level of confidence that you need. Put another way, the surest way to guarantee your UI tests are not fun to write is to use them to test the wrong things. So my team differentiates between 4 types of tests, which you see here, and each one is a different trade-off between the cost it takes to author and maintain the test and the confidence that we get from it. Right? Unit tests, very, very easy to write. They run very fast. That's great. They don't give us a whole lot of confidence. Right? That's how we have a ship going down with lots of green check marks. UI tests give us lots of good feedback, a lot of confidence in the system, but they're very expensive to write and maintain. And in the middle, you have different trade-offs along the way. So whenever we set out to write a test, the first question we ask is, what is the lowest test on this list that could conceivably give us the confidence that we need? And if the answer is UI test, the very next question we ask is, how can we change the code to change that answer? And here's an example. A common scenario we have, right, is that some piece of information is visible or hidden based on some business rule, right? Very, very common type of thing. My app deals with licensing and credentialing, certification. So the My Account page might have the rule that if the user has an active license, then we want to show it to them. And if they don't, we want to say not licensed or something along those lines, right? Very easy to write in some kind of view code. 30 seconds and you're done. But if this rule is important enough that it justifies a test, the only way to test this is with a UI test. That test would look kind of like this. Now, I'll go over all these patterns in a little bit, but the key point here is that to write a UI test for that piece of logic, we have to new up a user, we got to save them in the database, got to log in as that user, navigate to their My Account page, and then use Selenium WebDriver to check the DOM to see if the text that we want is visible. That's a crap ton of work for a little tiny piece of logic. And because we're good testers, we're going to want to test the negative case as well, right? So if you're not certified, you get the not licensed text to show up. So we copy-paste that test. We change a few Booleans to make it true to false. Now we have 2 tests, creating 2 users, both logging in and navigating to test one really tiny piece of logic, right? This is not a sustainable approach. So a better approach would be just to move that logic into like a view model where you can then unit test it, right? Very simple refactoring. You pull that conditional into a method, and then you write a unit test for that view model, which is really easy. You new something up in memory, You new up your view model, you call your method, and you do your assertion, right? This takes 1,000th of the time, or even better than a UI test. If you pull things into unit tests like this, you can more easily parameterize them. So in this case, I have one test that's testing both the positive and the negative condition, right? A little bit of conditional, or the parameters up here. So I cover both the case they are licensed and not licensed, and then one test does everything. And because these things run in memory, extremely fast. Now, to be fair, you can parameterize your UI tests. You could write a Selenium test that has a parameter like with the test case attribute. But because UI tests are making changes to your database, right? They're actually creating people in the database. They're logging in, they're changing data. You have a greater chance that those tests are going to conflict. They're going to try to modify the same person. They're going to create the same duplicate data. So in general, any kind of parameterized testing, it's much, much easier to do as a unit test and not a UI test. So the general point I'm making is that anytime you can refactor your code so that you can unit test a view model instead of DOM testing with a UI test, that's probably going to be a good idea. Now, it doesn't always work, right? This kind of test is not going to tell you if you display the text and then CSS hides it. It won't help you if you display the text and then JavaScript comes along and changes the DOM. So if the feature that you're dealing with has a lot of front-end interaction, a lot of dynamic pieces going on, you're doing something very complex in Angular or React or whatever, then yeah, maybe a UI test is the way that you need to do to get that confidence that you want. But if you're dealing with like a server-rendered HTML page on like a My Account or something, then yeah, pull that logic out of the UI into something you can more easily test. So if we want more confidence than we get from a unit test, the next best thing we can do is get rid of the mocks and hit a real database. And there's all kinds of things that we can do if we're hitting a real database and a real file system without using the UI, right? We can check for database changes. Some method changes the right data. You can look for file system updates, email delivery. All kinds of things can be done without standing up the browser. And the vast majority of the tests that we write that deal with real business logic are integration tests, right? We deliberately look for ways to put things into an API or some sort of easily accessible method that we can hit it with an integration test and not bother with the browser. So that brings us to UI tests, the most costly and the most valuable in terms of confidence that we get from them. So I just said that we use unit tests to test for calculations or visibility logic, and that we use integration tests for the business logic. So what does that leave for the UI test to focus on? We try to only write UI tests for things that cannot be tested any other way. If you think about it, there are lots of things that can happen that are not business logic related that you can only test for by having a full web stack with a browser coming in, parsing the HTML, and running the JavaScript. So let's say you have a very simple edit form, right? This is a simple form with 2 fields, a submit button, and a little bit of JavaScript. It displays some data, and the user can make a change and hit submit. Think of all the things that could go wrong here. Maybe the code that renders that form doesn't initialize the default values properly. So the form pops up and the fields are empty, right? Maybe the form uses a jQuery plugin, but there's some kind of JavaScript syntax error. So JS runtime just says, nope, I quit, I'm out. So your plugin never runs and the form field never gets initialized. Maybe someone changed a CSS class in the field but didn't change the JavaScript. So the plugin runs, initializes, but doesn't actually hook up to anything, and again, the form is not fully initialized. Or maybe the form is pointing to the wrong endpoint. Someone renamed the server action but didn't change this form, so we hit submit, we get a 404. Or maybe the field names that we're sending don't match up to the payload the server is looking for. Maybe the server wants data.foo and data.bar, but we're sending fields called foo and bar. Oops, yeah. So even if we send the right data, the server doesn't see it, it doesn't actually run the right changes. Those sorts of things are impossible to check for without using the browser. So that's what we focus our UI tests on. The UI tests are never, or almost never, about business logic and all about can the user come in and use the browser to do the user interactivity stuff, and is all the kind of framework pieces coming together to support that experience. So once you've decided you have something that really is worth testing in the UI, you can't refactor it, you got to write the actual test. And every UI test has to consider 4 things. What baseline data has to exist before the test can run? What user identity will be used to perform the test? How does the test navigate to the starting page, right, from which the test is going to begin? And once the browser is on that target page, how do we write good, clean, maintainable test code? And there are trade-offs and interesting things to talk about in all 4 of those areas. I'm going to start at the end with the test code and work our way backwards. Like many teams doing UI testing, we organize our tests using the PageObject pattern. So that has us create a PageObject class for every page or UI component that we want to test. So in this case, I'm going to show you an example of the PageObject for a login page. And the point of a PageObject is to create an API that your tests can use to interact with and automate that page. And the idea is that by writing your tests against that little API, you're going to decouple them from the actual HTML implementation. You're going to decouple them from the specific browser automation framework being used. And you're going to have cleaner, more maintainable, more intent-revealing tests. And the first thing that we do in a PageObject is to create public properties that represent the HTML elements on that page. In this case, it's a login page, so there's a username field, there's a password field, and then there's a submit button. Now, how you actually implement these properties is going to depend on what you're using to automate the browser. We use Selenium WebDriver, and that gives us this handy finds by attribute. This finds by attribute lets us declaratively bind these properties to the DOM. So and this says if my code comes in and says, hey, I want to interact with a username field, right, that's bound to an HTML element with an ID of username. So Selenium is going to take care of giving me some kind of proxy object in my C# code that I can use to drive the browser. So our most commonly used locator is an ID, but we also use a class name or a CSS selector. So the point here is that you focus on the locator, right, just sort of how you want to find the thing in the DOM, and Selenium WebDriver does all the rest, right? You just you bind it like this, you ask for the property, and WebDriver gives you an object that lets your test talk to the browser on that field, click the button, do the whatever. Now doing this means that the PageObject gives you an application-centric API for writing your tests, not an HTML-centric API. An application-centric API is focused around what the elements mean and how they can be used, not how they're implemented, right? They let a software client, like a test, do anything on that page that a user could do, but without knowing how it's built. And that's kind of how humans use the web too, right? We go to a web page and we see a username field. We don't know what table it's in, what ID it has, right? We just know there's a field called username, and I can click on it and type into it. That's what a PageObject gives to your test authors. An HTML-centric API requires test authors to know how all your fields are implemented, right? Every time you write a test with an HTML-centric approach, you got to know, is it username or user-name? Are we using IDs or classes on this page, right? How am I going to address that thing? And if your HTML changes, right, all of these HTML-centric tests need to be rewritten because that HTML implementation is baked into the test itself. So following the PageObject pattern makes the UI tests very easy to write, at least when the PageObject already exists. And if you see yourself putting HTML in your test code itself, then you're probably doing something wrong. You're probably shooting yourself in the foot, and I would recommend you stop doing that. Now, when we first started writing PageObjects, our test code looked like this. Each test would interact with the PageObject properties, right? It would say, I want to put this value in the username, this value in the password, then click submit. And the test would do all of its assertions, whatever it needs to do. Seems pretty simple, right? And it's definitely decoupled from the HTML structure, but this is still coupled to the HTML implementation. As an example, let's imagine for a moment that I have 5 tests I want to run for the login page. The first one says, if I have invalid credentials, I'm going to get a failed login with a message. If I have valid credentials but the account is locked, I'm going to get a different message. If I log in as an admin user, I get redirected to the admin dashboard. If I log in as a normal user, I get sent to the normal user dashboard. And if I log in and I have not changed my password in over like 3 months or whatever, it triggers the password reset. Now, before I move on, a quick pop quiz for those of you lucky people in here in 4. Why are these really bad examples of UI tests? Hard-coded? Kind of. I'm going to get there. You kind of jumped ahead a little bit. This is bad because that's business logic that we're testing. Things like when I'm an admin, I go to the admin dashboard, and when my account is locked, I can't log in. That's business logic. That does not need to be tested through the UI. Right? That type of thing should be pulled down into a lower level class that you can unit test or integration test. So in a real kind of example, or a real site, I'd probably have one test that did a successful login, one that did a failed login, but all of this kind of reasons that you could fail, I would pull out into individual lower level tests. Let's pretend for a moment that I was not being very lazy in my slides, and I admit that I was. But if I wasn't being lazy, and those are good examples of UI tests, right? Each test has to do the same 3 things, like someone mentioned. You have to put a value into the username field, a value in the password field, and click submit, right? That's a lot of duplication. Let's say someone in legal comes over. So Larry from legal comes over and he's like, hey man, I'm freaked out about GDPR. I think we're using cookies. Everyone has to acknowledge the privacy policy before they can log in. Put a checkbox in the login page, make them click it before they can log in. If that happens, then I have to go to all 5 of these tests and add that checkbox to them. And that's because these tests are coupled to the front-end implementation. So over time, we've started adding behavior to our page objects as well. In the case of the login page, right, we'd have like a login as method. It takes a username and a password parameter, and that method does all the things that have to happen for logging in. So if you added that checkbox that Larry from legal wants, it would just go into that login as method, and our tests would not need changed. And in fact, we've started making most of the properties on our page objects private. We've started forcing developers to use methods as the primary way that they interact with the page object, because we found that when you're focused on just sort of field level manipulation, there's usually a higher order thing you could express with a method, right? You're logging in, you are deleting the product, you are, I don't know, whatever makes sense to your application. Your methods can provide context. So sort of like the page object level 200, 300 approach is no public properties. It's all methods, and your tests are using those method calls to drive the page. We also put this go-to-page method on all of our page objects, and that makes it easy for tests to navigate to the page or context that you want to test. When we first started out, we did everything in our test the same way that a user would do in the site. So that means that we would have someone log in, then the test would go and click on the menu item, and it would then click down here, and then go to some intermediate page, and then click from there. The same path that a user would follow. And that made the tests really painful to write because you're doing this very annoying thing over and over again. It made the test slow because sometimes the intermediate pages that you don't even need take a while to render. And it made the test brittle. Now, at one point, we had like 50 tests for the admin area of the site. And all 50 would log in, they'd click the administrator link in the menu, and they'd click on some link, and they'd go about their business. Well, our UI tests run nightly in the same database that we use for manual testing. So one day, a QA person changes, they rename that menu icon, because our software is very configurable. They renamed the menu icon to say admin. Next morning, we come in, we have 50 failed UI tests. Like, holy crap, what happened? Nothing, right? The site was still fine. So the lesson is that every interaction that you automate is a potential point of failure. So you really only want to automate the things that matter to your test case. You probably do want at least one test that's going to go through your menu and make sure the links work. You want to make sure that there's at least one test that clicks on various links and they still work. But once you have that, all of your kind of other tests that you write, just have them go right to the page. And this go-to page method is how we do that. And the nice thing about this approach is that we can document the required URL parameters in that go-to page method. So the login page, for instance, has no required parameters, right? You can optionally tell it where to go after you redirect, but that's optional. The member details page, though, has a required parameter. You can't see the member detail page without telling us what member you want to see. By baking that stuff into this go-to page method, we ensure a programmer can never navigate to a page without providing the right parameters, right? They can never misspell the URL parameter. It's all baked into this method. And down the road, if we change what parameters you need to load a page, right, IntelliSense or static analysis tools, the compiler can all be used to tell us, hey, these tests might need to be updated because you've changed what's necessary for a certain page. So I want to wrap up the section on page objects with one last comment. Even though this is called the page object pattern, it does not have to be used at the page level. You can create a page object for any significant element in your UI. So we have this concept of a comparison rule. It's a little feature we have that we use on 15, 20 different parts of our site. And it's implemented as a modal pop-up. It pops up, you make some changes into it, you hit a button, and it writes some JSON into a hidden form field, right? So it's not a page, it's just a div that we float on the page with some CSS and some functionality. But because we reuse it, right, it has its own page object. So we have some feature page, it does some stuff. There's a method on that feature page that says configure comparison rule, and that returns the page object for that comparison rule editor. And you note here, I'm not doing like comparison rule editor dot field one dot set value, right? I'm doing something very application centric. Configure a rule, and here's some data, right? So this makes it a very expressive, very easy to read and maintain test for kind of componentizing a piece of your UI. You can also do this on a single page application, right? You only have a single page, but you have multiple views or contexts that could be active. So you could have a page object for every view or context, and there could be some method that is used to put the single page app into that view or context, right? It can be used to do whatever you need to do to get to the point where you can interact with that page. Right? This might just be navigation, it might be more complex. You can imagine maybe it's like a checkout page, right? And you want to test the very last page of checkout. There's no reason that the go-to page couldn't put things in a cart, and start checkout, fill in the shipping address, and so forth, right? So whatever you want to make it very, very easy to get to the point where you're writing your test, that's the point of page objects and the go-to page method. So a few slides ago, I said that every UI test had to consider these 4 things. And the page objects do 3 of the 4, right? They give you the API that you need to automate the browser. They handle the navigation to the page in question using the go-to page pattern. And reusing the login page, page object lets us very easily control who's logging in for each test. So that brings us to the very first thing you need to consider when writing a test, which is what data needs to exist up front before your test can run, and how does that data get there? And the answer is that it's complicated. And it's even more complicated if you have a complicated data model. So as an example, the main product that my team develops is in the licensing and credentialing space. And one of the things that we can do is automate the workflow or configure the workflow that someone goes through when they're applying to have a credential in a field like hairdressing or real estate or nursing or nuclear engineering. And those are all 4 legitimate examples for my software. We have clients in all those spaces. As you can imagine, the rules that you might go through to apply for a nuclear engineering type license versus what you need for a hairdresser license are very different. But there's a lot of common things. You got to fill out a whole bunch of forms. You might need to pay a fee. There could be a background check. There could be, someone needs to call and verify a transcript. So all these things need to be configurable in my system, and that means that we have a very complex data model. But we realized that the data entry forms that can hold all kinds of data, right, they're very configurable, that was a key part of the UI. So we needed to have UI tests. But we realized very early on that managing the test data for those types of very configurable features was going to be very challenging. If we did it wrong, we were not going to be able to keep our costs under control. As an example, let's say we want to write a UI test for one of my data entry forms. Well, obviously the form has to exist in the database before we can hit it with the UI. So the first decision we have to make is, are we going to render a form that already exists, or are we going to create something brand new for this test? So let's say that developers on our team all have a common baseline. Maybe we all have a standard database that we restore from, or there's a common test data script, whatever. Everyone has the same baseline data. If that baseline data already has a data entry form in it, then we could just create a constant that gives us the ID of that thing, and we can just use what already exists, right? And then the test is really easy to write because there's no setup. I just use the thing that already exists, and I'm off to the races. In the beginning, that's pretty easy to do, right? You pick your one test you want to use, and now you have one thing in your list of constants. But things don't stay simple over time. And sooner or later, we're going to write other types of tests that need other types of data. Maybe we have a test that deals with fees, so we have to have a specific fee configuration. And the next one comes along, and it deals with a different type of UI, right? We want to see how this thing renders with one UI config versus the other. Then maybe there's a specific background process or a workflow that we want to test. We want to see what happens when someone's configured for a manual review step. So the programmers writing these tests are going to do the logical thing, right? They're going to configure the data they need. They're going to push it into that baseline, and they're going to add a new ID to this list, and that's how it's going to change over time. But as that grows, it gets really, really nasty, right? And eventually, it's hard to figure out, even if you've been around for a while, which of these things that already exists is in the configuration you need for your new test. Let's say you hire some new developer, right, and she has to write her own test. Her chance of figuring out which of these things matches what her use case is nil. So she will also do the logical thing. She'll say, I don't know what the heck all this stuff is. I'll make a new thing, I'll shove it to that baseline, and I'll write my own test. So over time, this becomes like an append-only list, right? And your chances of finding duplicates skyrockets because no one can remember or figure out which of the 20 things that exist is suitable for their specific need. Now, I made up all of these things for this test. These are contrived examples, but this is actually a very real problem. In a complex system, the need to highly specify the context for any given test is an ever-present issue. And if you go this route, you will very quickly just bear yourself under the weight of all these things. So another approach would be to maintain a smaller list of pre-built things and just modify them in every test, right? So maybe we start off with the form that has an application fee, and we say, well, this test, I'm going to go ahead and configure it to be the multi-tab UI as well. Then I'll do my test. And this does reduce the number of pre-built things that you need, but it's really a bad idea in practice. Because now every test is making permanent changes to shared global data. And that's really bad. Right? You might get different results if you run your tests in different orders, because you never really know what state the data is going to be in, because you don't know which tests have already been monkeying with it. So for those reasons, I'm a die-hard, card-carrying member of the every test creates its own data club, right? I think every test should make the fewest possible assumptions about the data that already exist, and it should be precise and explicit about what properties of the data it needs to create for its test. And this is I think a bigger issue in UI testing than in integration testing. In our integration tests, we can, we'll write automatic rollback transactions. So we can change all the data that we want, test is done, and we can just roll it back, no problem. But we can't easily roll back changes from our UI test, which is why I think that prior approach of changing data as you go does not work in the UI. This is probably the one principle that's been the most significant for us over time still being successful with testing, is making sure that these tests are self-contained things that create their own data. Let's go back to that pretend test that we're trying to write. And instead of using pre-built data, let's have the test create the data that it needs, kind of as it goes in the body of the test. This is what it might look like. So first, we got to create that thing that we want to have exist in memory. So we new it up. We got to specify the data that matters. We got to configure it for the test at hand. And then we got to put it in the database so that the UI can access it. And the good news is that this test is now totally independent of all the others, right? But there's still a problem here. If I were to make this code more realistic, then creating a data entry form will require a thing called a credential and the member that owns it. But it turns out that a credential has this thing called an interval that it needs, and a member needs some address data, and each of those things may have their own dependencies. And by the time that we've satisfied all the constructors, we've had to specify a whole bunch of data that has no bearing. It's totally irrelevant to the test that we want to write. So all those values that we wrote that are irrelevant, they make the test harder to write, they make it harder to read, and they obscure the data that actually matter. Those noise values also make our test brittle, right? Anytime we change the constructors for these things, I have to go back to all my tests and make changes. I don't really want to do that. And of course, all that code was just for creating the thing in memory, right? We still got to put it in the database so that UI can go and hit it. There's a lot of problems there too, right? You got to deal with foreign key constraints. You got to create the data in the right sequence because you can't create the order before the member exists or whatever. And if the database is assigning IDs, then we got to get all those assigned IDs back into the object graph in memory so the tests can access them. There's lots of stuff living in that save that can be complex. So obviously it can be hard to create test-specific data. And to make it easier, we've created a library of data creation helpers that make it much easier to construct the test data that we need for not just our UI tests, but all of our tests. And this is what they look like. For every entity foo that we will have a class called fooHelper. And fooHelper has a create method. And the create method will expose every piece of data that can be customized as optional parameters. So when tests call the create method, they only specify the things that they actually care about. The helpers will then provide a reasonable default for anything not specified. And the helper will return a fully built object with all the dependencies in place that represents a legit business scenario. So we're not just creating nulls or empty arrays, right? We are creating the whole object graph representing a valid business state. And for writing like an integration or a UI test, we'll call a second method called save that persists those things into the database. That save method is what deals with the foreign key constraints. It's what deals with the sequencing. It's what makes sure that all of the IDs get put back on the object graph. We call these things test helpers, and the really nice thing is that we use this for all of our tests, right? We use it for unit tests, integration, and UI. And if we start out with a unit test, and we want to make it into a UI or integration test, we just add the save method. This is not the only way to create test data, right? There are generic libraries that you can get that'll create data for you. We've decided, and you might be able to use like your own ORM or your data services to save, right? You may not need to go this route. This route works really well for us because it lets us deal with the complexity in our business rules by managing the default values, right? If you're using some off-the-shelf library, you might have the need where you say, well, the default value for property B kind of depends on property A, right? If we want it to be a valid business scenario. That's harder to do with an off-the-shelf library. If you roll your own, it gives you a very logical place to put that kind of stuff. So again, you could use an off-the-shelf library, but we've had a lot of success doing this. It's been very, very helpful for us. I could go on and on about this stuff. I have a whole talk just on that test helper pattern. But for today, I want to focus on these two key points. Number one, don't new up your test data by hand, right? Wrap it in some kind of API that deals with that construction for you. And number two, when you create test data, only provide the values that actually impact the test outcome, right? Let the helpers give you defaults for everything else. This image here is from a blog post by Stephen Hicks, and he uses the concept of Chekhov's gun to explain this last point. Chekhov's gun is a principle in dramatic writing that says that all elements of a story should be related in some way, should be relevant. So he's quoted as saying, If in the first act you hang a pistol on the wall, in the following act it should be fired. Right? The point is, don't show things to your audience if they're irrelevant, if they don't matter, if it's distracting, misleading. That same principle applies to your tests. If you provide a value when you're creating data, that value should impact the test in some meaningful way. If it does not, then it is misleading, it's confusing, and it does not belong. Right? This is a really, really important principle to keep your tests set up manageable, and that'll go a long way to making your UI tests a little easier to write. There's one other problem that you might run into when you're creating data for each test. This is specific to UI testing. That's caching. So if you're running a website and it has a cache in browser memory in one process, and your tests are over here changing the database in their own process, doing direct database calls, that web cache may get stale, right? It'll get out of sync. So a simple way to solve that is to create just some endpoint that you can call that will just drop the cache. And then we have a helper method on our base test class that just makes an AJAX call out to that endpoint. So any test that creates data that we know is cached and we know their website's running, we'll just make a call to that method. It'll make an AJAX call, wipe the cache, and everything will be happy. So here are your two options when it comes to test data. You can use data that already exists, right? That's easy, but managing that data is really hard over time. It's also a bad approach when your tests need to modify data or make changes, because now you have tests changing data that other tests depend on, and they may start fighting over that data. If you create the data that you need in each test, then your tests are easier to read, they're easier to understand, and a good library of helpers goes a long way to making that easy to do. If you go this route, you do have the issue where every test run is going to create more and more data in your database. So to deal with that, you're going to want either test teardown code that's going to clean up after every test, or you're going to want to write some scripts that'll just restore your database to a known clean state on demand. That's what we do. We have a easy rate command that we run that'll just drop and restore the database to its known baseline. So we've been doing this for years, and it has really been just transformative in our ability to keep writing tests and maintain a stable velocity over time. The test helpers and the automation scripting is not free. Right? It does take some effort, but it's totally worth it. Right? I can't imagine being successful with a different approach. So using pre-built data is one anti-pattern that'll make your tests really not fun to write. Another anti-pattern for UI testing is using the side effect of one test as the starting point for another. So let's say that your site lets people create and edit widgets, right? So it might seem like a really good idea to write tests like this. Test 1 goes to the new widget form and submits it, which creates a widget in the database. Test 2 goes and hits the edit page and edits the thing you just created. So now you know the edit page works. Then test 3 goes and hits the delete page and deletes the thing that you just created. And if those were the only 3 tests that you wrote, that's really not bad, actually. It's a nice little decent, pragmatic, self-contained package. It covers a logical progression of the application. It does not depend on pre-built data, and it cleans up after itself. Right? There are far worse things than this little package. The problem is that things don't stay simple, right? And over time, you're going to be adding more and more things, and this package won't be small and contained anymore. So presumably, widgets exist for some reason beyond just being created and edited and deleted. So you're probably going to want some UI test that goes elsewhere in your site and uses the widget in some way. So developers are lazy, right? So we're going to say, well, I already have a thing right here. Why not just put a test in the middle? I go and use it, and then we delete it, right? No big deal. The thing already exists. It's a nice, easy thing to do. My test will be easy to write. That's what I'm going to do. But later on, right, software evolves. So we add this new thing called widget type. And widget type has some property that really changes how the UI reacts. So now we say, well, we kind of want to make sure that we view or use both a type 1 and a type 2 widget. Let's assume that things become type 1 by default. So our create test will be creating a type 1 widget, And our first use widget test will become a use type 1 widget. So the next lazy developer, again, because we're lazy, is going to clone that test, copy, Control-C, Control-V. They're going to write a little bit of a SQL maybe just to flip the type flag to type 2 and repeat the same test. So now you have, right, you edit, you do your view, you flip the type, and you view again. And you still have pretty good test coverage here, right? We're covering both the edit or the view of both types, and we're cleaning up after ourselves. But it's not a nice, neat little package. And if we keep following this pattern, it's going to get more and more harder to maintain. So tests written like this are hard to understand because when you come along later, you never really know what the test context is, the data context. Because the only way to understand what data exists right here is to understand the cumulative effect of every prior test. And that becomes really hard. It's easy when you're first writing it, but you don't want to be the person who has to maintain this a year later. And if one of these tests fails, it might cause everything behind it to fail as well. Right? If the edit test fails for some reason, then all the ones that follow could also fail. And this prevents you from running your tests in isolation or individually. UI tests are incredibly slow. You are going to want to write or to run smaller subsets at a certain time, right? You wake up in the morning, you look at your test run, and you have 11 failed tests. You're going to want to be able to run those and troubleshoot them without running your whole suite. But when each individual test depends on the stuff before it, it's really hard to do that. So my advice is you should never chain UI tests together like this, right? It seems pragmatic. It will make your tests very unfun to write. If you want to do an end-to-end test, that's great, right? But have each of these tests should be self-contained and individual so that you can scale and be able to run them individually. So at this point, I've shown you how we use the PageObject pattern to organize our tests, how we use test helpers to control the test data. In the last part, I want to talk about writing more resilient UI tests. When we first started writing our UI tests, for some reason, developers tried to write the test code without making any changes to the UI code itself. I don't know why we thought we needed to do that, but we felt like maybe, I don't know why, but we tried to say, I'm going to write this test and not change the UI code that I'm dealing with. So if the HTML was complex and the test needed to get a very precise part of it, we ended up with page objects like this. And this locator is looking for a link that is the direct child of the first span, that's the direct child of a TD, that's the direct child of a table row with a certain class. Now hopefully you can already see why that would be very brittle. Right? Even a tiny change to this HTML is going to, like changing that span to a div, right? Will break every test depending on this page object. So to avoid things like that, we encourage developers to modify the UI code to make it easier to test. And one way of doing that is to create test-specific IDs, classes, and data attributes that are used only by the UI tests. When we do this, we include a Selenium prefix in the ID or class name or whatever that is it's a very clear signal that those things should not be used for styling and not be used for functional JavaScript. And we encourage the separation because it makes it far less likely that a designer is going to come in and accidentally change or break your test by changing the styles, or that another programmer will break your test by changing some JavaScript. Right? The Selenium prefix says, hey, it's a very clear sign that tests care about this, and before you change it, you should understand what the tests are doing, and then not be surprised when they break. And every once in a while, you might run into a scenario that makes it hard to use test markers like this, where you can't make this change. So in that case, if you can't bind a page object right to like a test-specific ID, then you want to use a locator that's the most resilient to change. And to do that, you can use this concept called the locator tree of life. And this is basically a way of thinking about locators that encourages you to write more resilient and maintainable code. And the idea is that the fruit at the bottom of this tree is tasty and healthy, and you can eat all that you want. But as you go up the tree, the fruit becomes more and more bitter, and you want to avoid it or eat it in moderation. So things at the bottom, like ID, class, and data, tend to be easier to use and more resilient to change. So as an example, let's say I have a piece of HTML. It's got an ID, right, in it. And there's a page object that's bound to that ID. So if a programmer comes along to make changes to this code, and they happen to search for that ID over the system, they're going to find that test, right? A text search can very easily notify them or alert them that tests care about this, and they can use those tests to factor into their process. But things get more difficult as you go up the tree. So here's another piece of HTML. I got a table, a bunch of stuff here, and then there's a page object that's bound to it using a path type locator. It's looking for the link that's a direct child of the TD, the direct child, and so forth. Nothing about this HTML fragment tells someone that adding a div around that link is going to break anything. And there's no text search you can run to figure that out. Right? The best you could do here is say, oh, I'll search for foo. Maybe you'll find foo down here. But what if the table row comes from like a partial view or some kind of include file where the table itself is declared in a different file? It's very possible the person doing that HTML modification will have no indicator, nothing they can easily search on that would tell them some page object cares about this thing. So the lack of that obvious explicit link is what makes things like a path-based locator more brittle. So as a rule, we avoid locators based on paths, element text, position in a group, or any of that really cool but advanced stuff that CSS lets you do. Right? It's cool to have, but we avoid it for our tests. We focus on these low-hanging fruit, and if you combine these low-hanging fruit with like Selenium-specific markers, then you end up with tests that are very, very resilient because people can very easily realize what they need to do to keep their tests in sync with their code. So to wrap up, I want to summarize the main things I want you to remember when you leave. So first, create a deliberate test strategy, right? And you should endeavor to validate business rules and other logic below the UI, right? You write the UI tests only for things that you cannot test any other way. And if you find yourself testing what feels like business logic in the UI, refactor the code, right? Find some way to make that not the scenario. And make that strategy a first-class part of your process. This is not something that your QA people should be figuring out after you throw code over the wall, right? We do it's like called a 3 amigos process. At the start of every story, QA, dev, analysts sit down, they talk about the story, and they include the test strategy up front. So before we start writing code, we have an idea of what we need to do with the UI and what we're going to test elsewhere. Number 2, use the page object pattern to create an application-centric API for your tests, right? If you put all of that HTML stuff in that one abstraction layer, your tests are going to be really easy to write and easier to maintain. And number 3, each test should create its own test data. Do not rely on pre-built things in the database because it does not scale. It might seem painful at first, but that helper library of data creation helpers will go a long way to making it maintainable. And if you do use those helpers to create test data, right, only specify the values that impact the outcome. Right? Remember Chekhov's gun. Do not mislead your future maintainers by having irrelevant data in that test. That's it. Here's those three things if you want to screenshot them or do whatever with them. And the best ways to get a hold of me. And I think this is our questions down here, although I do have a few minutes so I can take questions either here or over the proctor. So thank you and have fun testing.
All right, lunch is being served.
Oh.
There are 4 Slack questions that I would like you to address if possible.
Okay.
But you don't have to stay for that.
Yep. If you want to go eat, you won't hurt my feelings.
If you want to go eat, that's fine too.
I get it, trust me, I'm hungry too. All right, so question number 1, are you not concerned that by building these helpers that you are violating your rule not to put business logic into your tests? And if so, have you considered using your biz logic? Okay, so the question is there business logic that's being put into those data helpers? And I will look, I guess, at you as you all leave. The answer is yes, but we use the helpers in all of our tests. So UI, integration, whatever. So the point is that the helpers may reflect business logic by creating the data that satisfies it, but the UI test itself, the assertions that the UI tests make, are going to be things like are not going to be there to validate business logic. So an example would be if you have like, I don't know, some calculation. There's 5 possible outcomes. Don't have 5 UI tests to check each outcome. If there's some way to put that code into some lower level, then you don't need the UI. That's kind of what I meant by not testing business logic in the UI. Their Slack question was, what test database do we use? We use SQL Server. We have the full database stood up locally. You could do like SQLite or some kind of in-memory database. My feeling has always been I want my tests to give me confidence. And if I'm in prod on SQL Server and in dev in memory in SQLite, I don't have as much confidence. So an in-memory database like SQLite will run faster. There's a trade-off there. But I like using SQL Server and have the full stack running locally, and we are validating. I mean, it is as real as it's going to get when someone's hitting the site with one of those tests. Do we do anything with design level testing? I'm not sure exactly what that means, so the answer is probably no, but I do want to know more about it. So whoever asked that on Slack, I'd love to talk to you more and find out what you mean. Sorry, I can't answer your question. And do you strip out the Selenium class name classes from your markup, or do they exist in production? They're in production. And we talked about pulling them out, but we're talking about, 2 or 3 of these markers on a page that's got a ton of stuff. It's rounding error, right? It's not a big deal. It's not impacting our performance. We are not a site that cares about squeezing every last byte out of the payload. That's not where our problems lie. If that's you, then yeah, you might want to do some kind of post-processing to pull those things out. But no, we have, those markers are in there in the code. If you view source, you will see them. It's not been a problem. Any questions for you brave people who stuck with me? Awesome. All right, well, I want to thank you for your time. Let's go eat. Thank you for that. I'm still on.